Okay, hello everyone. Welcome. Hopefully this works well. This video is for students at Wagga Wagga Christian College, and it is to show the workflow that we use to take files and creations, shapes and models from our CAD software that we use, Autodesk Fusion 360, and take it directly to the current CNC router table in D5. So this is the workflow we'll go through to create an outputted file that is ready to carve, if all is set up correctly, on that machine. To start with here, you'll see I've got a very basic shape. I want to identify that this curved section here is the front. Very basic, but it'll show more than what we need to for this demonstration. So the curved section is our front and this is our rear section, and we are currently in, if you see where my mouse is, if you follow through, in the design tab. While in the design tab, we need to do one thing and then we leave there. So I'm going to zoom in on the rear section of our car. We need to put a sketch on the rear section, okay? So let's go create a sketch on this face, and we want to get right around the center of this section. We want to create a place center point. We want to create a circle, and I'm also going to put in 2 lines, okay? Just cutting right down this central section, okay? Now I've noticed that circle's not quite center, but it actually should work fine for the purpose. Oh no, it's center to the top of to the top of our item. I've just noticed this gap there. Okay, with a circle there that looks similar to a crosshairs. If you're familiar with a crosshair, we can now proceed to a new use section within Fusion 360, and that is our manufacture tab. So I would like, if you need to, pause the video if you want to, if you're following along, but I'd like you to go to manufacture. When we're in the manufacture tab, you'll notice, if you follow my mouse again, across the top here, we have quite a few new icons, okay? These are our icons to talk to the machine that we're going to use and to set the processes. Some of these icons, such as in this area here, are for a machine that just moves 2-dimensionally across one plane, which is a common machine you may find out in industry. We are going to use the 3D functions because our machine can go up and down and use 3-dimensional functions. There are a few different ones here, different ones that are suitable for different sort of applications. I want to mention here, and sort of try and lock it into your head for later, adaptive clearing is what I will use today, the adaptive clearing method, okay? It's what I've selected to use the adaptive clearing for 2 reasons. One, it's what I'm most familiar with in my own exploration of CNC machines, computer numeric controlled machines. 2, I've already tested and confirmed that it works for the workflow that we're dealing with today. And what that means is I know for certain that it works taking a file from Fusion 360 to the Wagga Wagga Christian College CNC router table. So that is why I would like to stick with adaptive clearing. Why I'm making a particular mention of that, I'm nearly certain that parallel clearing that I'm hovering over now will also work. And if it does work, I suspect it might be more suitable. So I would love for you to try, and I'll probably try myself after making this video when I get the next opportunity to. I think there's one, we've tried it before and it didn't work, and I think I've worked out what was missing there. But for the sake of ensuring success, I want us to click adaptive clearing, okay? So we will click adaptive clearing. Let's try it, okay? Tool. We need to do a few things. I'll try and explain things as we go. Hopefully that's not too noisy. There's a machine that turns itself on behind me when it wants to work. Okay, so I'm going to go into tool and select my tool. For the sake of this video, I'm going to select the 6mm ball end mill, and let's just let it load and think about that. There are many different tools you can use, ball end mills, flat mills, flute, like multiple flutes, straight cutting flutes, or spiral flutes. They have very big impacts, depending on the cooling of the tool bit, what they use to cut through, the finish you would like. So we want milling tools metric, I believe. And we want to scroll down to 6mm ball end mill. 6mm diameter, that's the symbol for diameter just there, ball end mill. I'll double click that and give it time to think. Apologies again, if that machine's noisy, I'll try and talk a bit louder. It likes to turn itself off. Okay, we've got our ball end mill there, and we also have coolant set to flood. I think that's very important too, from what I've ascertained, okay? And you'll now see on our section here that there is now an image of our ball end mill. Now, this is not currently suitable. We need, for the sake of this process, we need our ball end mill to come from both sides, or we need our cutting tool to come from both sides. So we need to change how this works. Click through geometry, set different tabs, machining boundary. I don't suspect we need any of that. If we're having errors, this is where I might make a secondary video that goes into clearance heights. We will need to change our bottom, but we need to first we need to set an orientation. Passes, linking. Perhaps we need to be in setup. Apologies, I'm just running through checking. Feed and speed, shaft holder. Let's click OK, although I'm not sure. I suspect we might have done something wrong. I might have to pause the video here and ensure I can